Now, it's quite fascinating how map projections actually work, and also how every single map projection in some special way distorts the surface of the Earth. You see, map projections are methods of portraying part or all of the curved surface of the Earth on a flat surface of a map. Because the shape of our planet is a sphere that is slightly flattened at the poles and bulging at the equator in the form of an oblate spheroid, this is not an easy task. It's like peeling an orange and making that peel flat. You can peel the orange in many different ways, and you will still have difficulty making the peel completely flat without tearing or squishing it. And if 10 people peeled an orange this way, each person would peel it differently. The same applies to the surface of the Earth when we try to represent it on a map. It's impossible to flatten the Earth's curved surface without tearing and stretching it. Therefore, every single map projection introduces distortion, and every map projection tears or stretches the Earth's surface a bit differently. Some map projections may preserve relative areas, others may preserve local angles, and some may preserve only certain distances. This is why we have hundreds of map projections to use for representing the Earth's surface on a map. It's also very important to acknowledge that no map projection can preserve shapes, and no map projection can preserve all distances on a map. This is mathematically impossible. There are two common misconceptions about map projections that we hear a lot. There are also two main factors to consider when creating a map and choosing an appropriate map projection. The first is the size of the surface we want to represent. If we display on a map only a small portion, such as a small continent or a country, it's much easier to control the distortions compared to a map of the whole world. Because world maps represent the whole planet, we can much more easily recognize these distortions. This is why it's so important that world maps are represented using the appropriate map projection. The second factor is the purpose of the map. When the purpose of the map is to make measurements or display results from a spatial analysis, we need to select a different map projection. For example, the Mercator projection represents rhumb lines as straight lines. Due to this property, the projection became the standard for marine navigation in the 18th century because sailors could measure their compass bearings on the map. In contrast, representing world population density on a Mercator map is problematic because land masses such as Greenland and Antarctica appear far larger than they actually are relative to land masses near the equator, such as Africa. For such maps, we need to use a map projection that preserves relative areas so we can correctly represent population densities on a map.